Hey everyone! Welcome to my teaching vlog. I am your teacher Trisha, and in this channel, we'll be diving into the fascinating world of mathematics. And our topic for today is principal roots in irrational numbers. Our objective in this topic are define principal roots, describe principal roots and tell whether they are rational or irrational. Third, determine between what two integers the square root of a number lie. Let's have a quick activity. Draw a happy face if the given number is rational and sad face if the given number is irrational. Okay, let's answer this. Only 1.758 and pi number is irrational numbers and other are rational numbers. Our rational numbers in our previous activity are 1.5, 0.01, 0.6, and 3 over 4. 1.5 can be expressed as 3 over 2, 0.01 can be expressed 1 over 100, 0.6 can be expressed 2 over 3, and 3 over 4 is already in fraction form. What is the common among these numbers? These are the numbers that can be expressed as a ratio of the two integers. Our irrational numbers are this one and the pi. Can you think the numbers that can divide to this number? None. How about the pi? 3.14, and there is no number can divide into a pi symbol. Numbers like this is called irrational numbers or numbers that cannot be expressed as a ratio of two integers are called irrational numbers. The square root symbol is also an example of irrational numbers. Let us discuss further what is radical. The radical or the square root symbol that is used to denote the square root or nth roots. The radical used to indicate a root is called radical, and this is therefore read x radical n or the nth root of x. In the radical symbol, the horizontal line is called the vinculum. The quantity under the vinculum is called radicand, and the quantity n written to the left. Let's talk about square root. As you can see, that is the example of table of squares. The square root is the inverse operation of squaring. The square root of 9 is the perfect square. Square root are the numbers that when you multiply by themselves is equal to radicand. Let us know what is the square root of 9. Positive 3 times positive 3 is equal to positive 9. Negative 3 times negative 3 is equal to negative 9. Therefore, the square root of 9 is equal to positive 3 or negative 3. What is a principal square root? Every positive number has two square roots. One is the positive and the other one is negative. Example is square root of 9 is equal to positive 3 and negative 3. The positive root is the principal root. If the radicand is a perfect square of a number, then the principal square root is rational. If the principal square root is a whole number or a fraction, then the principal root is rational. If the principal square root is a non-terminating or non-repeating decimal, then the principal square root is irrational. Let's try this. Number 1. Square root of 100. 100 is a perfect square, 10 squared. The square root of 100 is 10. Since 100 is a perfect square, then the principal square root is rational. The next one is square root of 1000. Think of a number multiplied by itself will give you a 1000. There is none. Actually, the value of square root of 1000 is this one. Since 1000 is not a perfect square number, then its principal square root is irrational. Number 3. Square root of 49 over 169. Square root of 49 is 7. And the square root of 169 is 13. Since 49 and 169 are both perfect square, then the principal square root is 7 over 13. And 7 over 13 is a rational number. Number 4. Square root of 16 is 4, but square root of 20 is not exact. The actual value of square root of 16 over 20 is this. Since 20 is not a perfect square, then the principal square root is irrational number. For the summary, here are the things that we discussed in this lesson. First, a real number has a principal root that is either rational or irrational. A perfect square number is the product of the number multiplied by itself. And third, a perfect square number has a rational principal root. And last one, the perfect square table is a great help in determining the two closest integers to the rational principal root. Thank you for joining me on this mathematical adventure. Until next time, keep exploring, keep learning, and keep loving mathematics.